Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 12th Physics Get More Than 95% Marks series. Chapter is Alternating Current, Chapter 7, NCERT Line by Line, Part 4. Before we begin, we request you to subscribe our channel if you have not subscribed it. Please like and share our videos among your friends and relatives so that they also get benefit of our video tutorials. Please get connected by writing comments on the videos so that you can express your feelings about your videos, and if you won't understand anything you can write in the comment box so that we can create a new videos for that topic by exclusively explaining that topic, and it will be dedicated to you. So let us begin our today's class. Today we'll start with AC voltage applied to a series LCR circuit. Figure 7.12 shows a series LCR circuit connected to a AC source E. As usual, we take the voltage of the source to be V is equal to Vm sine omega t. Now, let us try to derive the equation separately so that it will be easier for you. So, we can write V, the potential difference, is equal to Vm sine omega t. As we have written for other circuits. Now, if Q is the charge of capacitor and I is the current at time t, then by applying Kirchhoff's loop rule, Kirchhoff's loop rule, we can write by Kirchhoff's loop rule, we can write L di by dt plus IR for resistive circuit and Q by C for capacitive circuit is equal to V. This is the equation number 7.20 from your book. We want to determine the instantaneous current I and its phase relationship to be applied to alternate voltage V. Let us see the book. So 7.20 is derived here. We want to determine the instantaneous current I and its phase relationship to the applied alternate voltage V. We shall solve this problem by two methods. First, we use the technique of phasor, and in the second method we will solve equation 7.20 analytically to obtain the time dependence of t. So first, the Phasor diagram solution. From the circuit shown in figure 7.12, we see that resistor, inductor and capacitor are in series. Therefore, AC current in each element is the same at any time. Having the same amplitude and phase, let it be I is equal to Im sine omega t plus phi. So AC current is equal to Im I am AC current I is equal to Im sine omega t plus phi, where phi is the phase difference between the voltage across the source and the current in the circuit. So, on the basis of what we have learned in our previous section, we shall construct the Phasor diagram for the present case. Let I be the phasor representing the current in the circuit as given by equation 7.21. Further, let VL, VR and VC and V represents the voltage across the inductor, resistor, capacitor and the source respectively. From the previous section, we know that VR is parallel to I, VC is pi by 2 behind I and VL is pi by 2 ahead of I. So VL, VR, VC and I are shown in the figure 7.13a with appropriate phase relationship. So first one, VR is parallel to I. So VR is parallel to I. This is I, this is VR. Fine. Next, VL is pi by 2 ahead of I. VL is pi by 2. VL is denoting this side, so it is ahead of pi by 2 angle, this angle from with respect to I. And V and V VC is pi by 2 behind I and VC is pi by 2 behind I. So in this direction, pi by 2 behind I. So this figure tells that I is parallel to VR or VR is parallel to I, VL is pi by 2 ahead of I and VC is pi by 2 behind I. So we can easily define this diagram according to this relationship. Now VL, VR, VC and I are shown in figure this 7.13a with appropriate phase relationship. The length of this phasor or the amplitude of VR, VC and VL are VR M is equal to IMR, VC M is equal to IMXC and VIM is equal to IMXL. This is equation number 22. The voltage equation 7.20 of the current can be written as VL plus VR plus VC is equal to V. This is also well understood. All will be equal to AC voltage. Addition of summation of VL plus VC, VR plus VC will be equal to the source voltage, source voltage V. The phasor relation whose vertical component gives the above equation. Now VL plus VR plus BC is equal to V. This is 7.24. This relation represent in equation 7 in figure 7.13b. 7.13b. So let us see 7.13b. This is the figure. Since VC, VL and VL are always along the same line in the opposite direction, they can be combined into single phasor VC plus VI, BL, VC plus BL, which has a magnitude VCM minus VLM, magnitude of VCM minus VLM. Since V is represented as the hypotenuse of the right angle whose sides are VR and VC plus PL, the Pythagoras theorem gives Vm square is equal to VRM square plus VCM minus VLM whole square. Substituting the value of VRM, VCM, VLM from equation 7.22 into above equation VM square. So here here we have, in this equation we have put the value of VRM, which is IMR whole square, VCM as IMXC, and VLM as IMXL, and this as whole square. So IMXC minus IMXL whole square. So if we take IM common, then IM common square bracket I bracket R square XC minus XL whole square. So IM is equal to VM upon under root R square plus XC minus XL whole square. How it came? So here from this equation, one step we can write IM square bracket R square plus XC minus XL whole square is equal to VM square. So IM is equal to VM upon under root R square plus XC minus XL whole square. So IM is equal to this. Now IM is equal to this one. By analogy to the resistance of circuit, we introduce the impedance shade Z in an AC circuit. So we can write Im is equal to Vm upon Z, where this whole value is Z. So where Z is equal to under root R square plus XC minus XL whole square. This is equation 26, 7.26. Since phasor I is always parallel to phasor VR, the phase angle phi is the angle between VR and V. So can be determined from figure 7.14. Tan phi is equal to VCM minus VLM upon VRM. So tan phi is equal to perpendicular upon base. Perpendicular is VCM minus VLM upon V, and base is VRM. So using equation 7.22 we get tan phi is equal to XC minus XL upon R. So this is also called impedance diagram, where perpendicular is XC minus XL, base is the resistance, and the hypotenuse is the impedance Z. Equations 7.26 and 7.27 are graphically shown in figure 7.14. This is called impedance diagram, which is a right angle triangle with Z as hypotenuse. Equation 7.25a gives the amplitude of the current. Equation 7.27 gives the phase angle. So this is the phase angle. So we can write phase angle as phi is equal to tan inverse XC minus XL upon R, and this is called the phase angle. Now, equation 7.25a gives the amplitude of the current and equation 7.27 gives the phase angle. With this equation 7.21 is a completely specified. In if XC is greater than XL, phi is positive. So here if XC, this one is greater than XC is greater than XL, phi is positive. And circuit is predominantly capacitive. Consequently, the current in the circuit leads the source voltage. If Xc is smaller than XL, phi is negative. In that case, phi is negative and the circuit predominantly inductive. Consequently, the current in the circuit lags the source voltage. Figure 7.15 shows phasor diagram and variation of V with V and I with omega t for the case Xc is greater than XL. Thus, we obtained the amplitude of the phase of the current of an LCR circuit using the technique phasors. But this method of analyzing the circuit suffers from certain disadvantages. First, the phasor diagram says nothing about the initial condition. One can take any arbitrary value at t, say t1, as done throughout this chapter, and draw the different phasors which show the relative angle between different phasors. The solution so obtained is called steady state solution. This is not a general solution. Additionally, we do not have transient solution which exists even for v is equal to 0. The general solution is the sum of transient solution and the steady state solution. After sufficiently long time, the effect of transient solution die out and the behavior of circuit is described by the steady state solution. Now, this was the phasor analysis. Now we'll do analytical solution. So, analytical solution, let us explain you in a separately so that you can understand more easily. So, normal potential V is equal to, we can write Vm sine omega t as we have written previously in all the cases. And by Kirchhoff's law, we have already obtained in the we have already seen in the phasor implementation that by Kirchhoff's law, we can write L di by dt plus Ri plus Q by C gives V. And instead of this V, what we can write? Vm sine omega t. From where we got? From here we got. Now, we know that I is equal to the differentiation. If we differentiate q by dt, dq by dt, we get I. Therefore, if we do di by dt, Again, if we differentiate I, then we get d2q by dt square. Thus, in terms of q, the voltage equation becomes if we double differentiate this equation, if we differentiate this equation twice, then we get the voltage. Now we can write L, if we differentiate this one twice, then we get dl d2q upon dt plus, again if we can write r dq by dt, again if we write plus q upon c, which is equal to Vm sine omega t. So we have just double differentiate this equation di by dt, because we need to find the voltage in terms of charge. So we have done it. And if we simply differentiate this di by dt, that is r di by dt, we can write q and double differentiate it, q again if we differentiate q, then we get dq by dt. So here also double differentiation, and again here in this case also we have double differentiated, and uh, and instead of v we have already written Vm sine omega t, instead of this Vm sine omega t. So this is written in your book 7.28, equation 7.28. Please let me know if you are with me, and any problem you can write in the comment box. We'll try to explain it again wherever you have problem. This is like the equation for a forced damped oscillator. So now we can write Q is equal to Qm sine omega t plus theta. So dq by dt will be equal to Qm sine omega t is differentiation of sine omega t is cos omega t plus phi, and differentiation of omega t is omega, that is omega we have written here. Now if we again differentiate this, then we get d2q dt square is equal to cos omega t's differentiation is minus sine omega t, so minus sine omega t plus theta. Again if we differentiate qm omega, that will be equal to qm omega square, which will be ultimately qm omega square sine omega t plus theta. This is equation number, this was equation number 7.29b, and this one is 7.29a in your book. and last one is 7.29c in your book. Now substituting the values. Substituting these values in equation 7.28. Where is 7.28? We'll substitute these values here. After substituting the values, we get Qm omega r cos omega t plus theta plus xc minus xl sin omega t plus theta bracket closed is equal to Vm sin omega t. This is equation number 7.30, where we have used the relationship. So how we got, just we substitute the values in 7.28. So here we have substitute d2 q upon dt square value as this. Again dq by dt we have substitute as this, and we get this equation. Now this is 7.30 in your book, where we use the relation xc is equal to 1 upon omega c and xl is equal to omega l. Multiplying and dividing equation 37.30 by z. So multiplying and dividing equation 7.30 by z is equal to by z, which is equal to under root r square plus xc minus xl whole square. We have, if we do that, then we will get q m omega z upon bracket r upon z cos omega t plus theta plus xc minus xl upon z sin omega t plus theta. Bracket is closed. Vm sin omega t, which is equal to 7.31. Now let r upon z is equal to cos phi. Then we can write phi is equal to tan inverse xc minus xl upon r. This is equation 7.32. Substituting the value of 7.31 and simplifying, we get substituting the value in 7.31 and simplifying we get qm omega z cos omega t plus theta minus phi is equal to Vm sin omega t, which is equation 7.33. Comparing the two sides of the equation, so if we compare both the sides of the equation, comparing both sides of the equation we get Vm is equal to Qm Vm is equal to Qm omega z. So we can write Vm is equal to Im z. Instead of Qm omega we have written, so Im, where Im is equal to Qm omega. Now this we can write as equation 7.33a. Now, and theta minus phi is equal to minus pi by 2, or theta is equal to minus pi by 2 plus phi, which is equal to 7.33b. Now, therefore current in the circuit, so the current in the circuit I is equal to dq by dt, which is equal to qm omega cos omega t plus theta, which is equal to Im cos omega t plus theta. Therefore I is equal to, and instead of this we have written Im, so I is equal to Im cos omega t plus theta. This is equation 7.34. 7.34. Now, moving forward, we can write where Im is equal to Vm upon Z. So, where Im is equal to Vm upon Z, or we can write Vm upon the value of Z is R square plus Xc minus XL whole square. This is equation 7.34a, and phi is equal to tan inverse Xc minus XL upon R. Now, thus the analytical solution of amplitude and phase of the current in the circuit agrees with that obtained by the technique of phasors. So same value here, same value, yes, the same value was also obtained in the analytical phase by analytical phasor. So both of them agrees. In this video tutorial, we have basically explained the LCR circuit and its derivations for different physical components like I, the current, the phase value, the voltage, etc., impedance, etc., in two ways, in phasor way and the analytical way. So let us keep the lesson today's class till here itself. Before we close the class, we have a simple request. Please subscribe our channel if you have not subscribed yet. Please like and share our videos among your friends and relatives, and please click on the bell icon to get automatic notification whenever any video is uploaded by us, so that you can get automatically updated with our new videos and you will not miss any of our videos. There are a lot of videos we are creating for 12 different types of video: ncert line by line, ncert solutions, ncert different questions, important questions for the exams, ncert suggestions for 2019 boards. So a huge number of videos are there. There are already more than 250 videos in our channel, so it will be very difficult to search if you have not subscribed and not clicked on the bell note icon. Therefore, suggest you to click on the bell icon so that you can get automatic notification. Thank you for watching our videos and supporting us. Thank you very much.